2 of 12. Matrices. Learning outcomes. At the end of this lesson, students should be able to identify the different types of matrices. Perform operations on matrices. Okay, first let us look for the type of matrices. First we have row matrix. Row matrix is a 1 by n matrix, meaning that we only have one row and n columns. For example, 5 to 7 is a 1 by 3 matrix, which is row matrix. 3, 5 also row matrix. 0, 5, 7, 9 also row matrix, which is we have one row, 4 columns. Second type of matrix is column matrix. Column matrix is a m by 1 matrix, which is we have only one column. For example, we have 3, 4, 6, 9, which is we have 4 rows and one column. So we have 7, 5, 3, 5, 5. All of them are column matrices. We have square matrix. Square matrix is a matrix with the same number of rows and columns. If we can list out starting from 2 by 2, 3 by 3, 4 by 4, and so on. For example, we have 1, 1, 4, 6 is 2 by 2 matrix. 1, 1, 1, 2, 4, 7, 1, 4, 3 is 3 by 3 matrix. All of them are square matrices. Then we have zero or null matrix. Zero or null matrix is a matrix with all its entries being zero. In simple words, all of them are zero elements. For example, we have 0, 0, 0, 0, 2 by 2 matrix, 0, 0, 0, 0, 0, 0, 0, 0, 0, 3 by 3, 0 matrix. Then we have diagonal matrix. Diagonal matrix is a matrix, usually a square matrix, in which the entries outside the main diagonal are all zeros. For example, we have 1, 0, 0, 3. So 1, 3 known as main diagonal. So the main diagonal is 1, 3. And all the entry outside the main diagonal is 0. So this is known as diagonal matrix. Same as 3 by 3 matrix, we have 2, 0, 0, 0, 5, 0, 0, 0, 4. The main diagonal is 2, 5, 4, and the rest are 0, meaning that this is also diagonal matrix. Then we have identity matrix. Identity matrix is the square matrix which once on the main diagonal, meaning that the main diagonal, all the entries are 0. Sorry, the main diagonal, all the entries are 1 and the rest will be 0. And it is denoted by IN. N refer to the row and column. Because identity matrix is a square matrix, so the row and column will be the same. For example, we have 1, 0, 0, 1. If you observe carefully, the main diagonal is 1. All the entries for the main diagonal is 1, and the rest will be 0. Same as 3 by 3 matrix, the main diagonal, all is 1, and the rest will be 0. So this is identity matrix. So for this one, 1, 0, 0, 1, normally we denote it as I2, and this one is I3. Lower triangular matrix is a matrix with all the entries above the main diagonal are 0. For example, if we have this matrix, if you observe, this is the main diagonal, and the entries above the main diagonal are 0. So this is known as lower triangular matrix. And of course, we have another one, upper triangular matrix. I think you can guess this. How does this matrix look like? Upper triangular matrix is a matrix with all the entries below the main diagonal are 0. For example, so this is the main diagonal, 1, 2, 3, and the entries below the main diagonal are 0. Okay, next. Now we move to the matrix operation. First, we have the addition. For example, if we have matrix 1, 2, 3, 4 plus 4, 3, negative 5, 6. So firstly, how do we know the two matrices can be added or not? Of course, very easy to determine whether they can be added or not. These two matrices can be added only if they are of the same order. So for this example, the first matrix is 2 by 2, and the second matrix is 2 by 2. So clearly that these two matrices are of the same order. So then they can be added. Then how do we add two matrices? Very easy. We just need to add the corresponding element. So for the first matrix, for A11 is 1, and the second matrix A11 is 4. So we just added 1 plus 4, which is the answer should be 5, 5, negative 2, 10. Second example, so you have to tell me if they can be added or not. Yes, they cannot be added because clearly that these two matrices are not of the same order. The first matrix is 2 by 2 and the second matrix is 2 by 1. So they cannot be added since they are not of the same order. Then we have subtraction. So for the subtraction, the rule will be the same as addition. They can be added if they are of the same, they can be subtract if they are of the same order. For example, we have two matrices, and then these two matrices can be subtract because they are of the same order. The first matrix is 2 by 2 and the second matrix is 2 by 2. So how to subtract these two matrices? We just subtract the corresponding element, which is 2 minus 1, 3 minus 2, 4 minus 3, 5 minus 2. Then we have 1, 1, 1, 3. So how about these two matrices? They can be added or not? Yes, they cannot be added because they are not of the same order. So cannot be added since they are not of the same order. And the third operation is scalar multiplication. So for scalar multiplication, quite easy because we don't have any specific rule like addition and subtraction because it's just scalar multiplication. So for example, if we have negative 1 over 2 is a scalar, multiply with the matrix. Then we just multiply this scalar to every element for the matrix, which is we have negative 1, 2, negative 4, negative 5 over 2, 3, negative 7 over 2. Okay, you can scan the QR code to answer quiz 2. Thank you.